Hello everyone, my name is Anvita Bansal and we are back with another problem today. And the problem is inversion of array. So let's move to your SDE sheet and let's have a look at the problem. So inversion of array. Okay. So this problem says that for an array inversion count, you are given an array of integers and you need to find inversion count in an array. Okay. So for an array, what is inversion count? This is your given array. Okay, and you are returning 3. That is the inversion count for this array. So let's understand what is inversion count according to this problem. It says that inversion count indicates how far or close the array is from being sorted. If the array is already sorted, then inversion count is 0. Otherwise, if it is in reverse order, it will be the maximum. And in general cases, if two elements, let's say AI and AJ, right, they will form an inversion if your AI is greater than AJ, right, and I is less than J. So I'll explain what is your problem statement. So let me take this example. Let's have a look. Okay. Yeah, hi, this is live and we'll be discussing this problem statement. So let's have a look. Coming on to this, let me just take up the problem statement for you all. Okay, so this is your given array. Okay, fine. And let me just increase the font of this array so that you can understand it better. Okay, so what does your problem say? What will be the inversion count for this array? First, it is important for you to understand the problem itself. So the question says that if for a given I in which I is less than j, for that particular I, if ARR of I is greater than ARR of j, in that a case, your inversion count becomes 1, and as many such cases you get, you keep on adding such counts and then you finally return the total count. So let's have a look in this array. This is index 0, this is index 1, this is index 2, this is index. I don't think so I need to write indices. Let's directly iterate over the array and understand it. If I'm at this index at 2, let's check for the remaining indices in your array. So you get 4, 2 is less than 4. See, basically inversion, to give them a count of inversion, it's basically something inversion sort. We can, with this question, we will also get to understand about inversion sort. What do you mean by inversion sort? So using this inversion count algorithm, we are basically doing nothing but sorting our array. So, and in this problem, for this particular problem, you're going to return the count of this inversion. So coming back to what is inversion count. Okay, so you see that the given array is not in sorted order. So if it is not in sorted order and I wanted to sort it, so for this element, how far or how close it is from the element from which it needs to be swapped so that it can be in sorted state. Let's have a look. So 2, if I compare it with 4, just consider this as one of your arrays. So it is in sorted state. It is fine. Now come on to the next index that is 1. So 2 is greater than 1. In sorted array, this shouldn't be the case. So this makes us count 1. So this pair gives you count 1, right? Count will be 1. Let's check for more such pairs where ARR of I is less than ARR is greater than ARR of j, where I is less than j. So 2, 1, 2, 3 is such pair? No. It is in sorted state. 2, 5 is such pair? No. It is also in sorted state. Let's check for 4, 1. So 4 and 1 is also one such pair. So your count becomes 2 here. Let's check for more such cases. 4, 3 is also one such pair which will add to your inversion count. Why? Because in sorted state, 4 shouldn't come before 3. It should be after 3. So this is this inversion state which it comes in. Okay, then coming on to 4 with 5. So 4, 5 are in sorted state. So no more inversions for this element at least. Now let's come to 1 and check for the remaining elements of the array. 1 compared with 3, it's in the right state. 1 compared with 5, it's in the right state. Then coming on to 3 and checking for the other remaining elements of the array. 3 compared with 5, it's in the right state. So total inversion, what is the total inversion count? Don't add them up. I was already adding them. So basically you got one from here, one from here, one from here. So total inversion count is 3. I hope the problem statement is clear. Fine. So if I were to solve this problem with the approach which I just discussed, that was basically your brute force approach. And what am I doing? For every element in array, I am checking for all the n minus I elements, right? If let's say 1, 2, 3, 4, 5, n is 5 here, and you are at 0th index, so n minus I minus 1, you are checking for all the remaining elements, right? If your I is 0, then you are checking for how many elements? 1, 2, 3, 4 elements, right? So basically there will be two for loops starting from I0 till n minus 1th index, or n minus 2 can also be the case, but okay. Then you start your j from which index? J starts from I plus 1 and goes till the end, right? N minus 1. You can make it n minus 2 also, so that your j can follow. Otherwise it will itself not come in this for loop and will be done with all the cases. Then what do we check? That arr of I, if arr of I is what? It is greater than arr of j. We always know we are iterating in such a way that I is always less than j. So you can also make it I is less than j, and we are checking for the remaining elements, right? For I0, I'm checking from index 1 till last index, then incrementing the count of I1, starting my comparison from I is equals to 2 till the last value for this, and finally the last element will not add up to the count. Okay, then if this is the case, you increase the count by 1, right? And that is your problem, and you have solved it in O n square of time complexity. N, because n is the length of your array, and you are running two for loops. Precisely, it's n into n minus 1, but it in terms of time complexity, we can write it as big O of n square. Okay. Now the problem is that, okay, this is the brute force approach, the very intuitive one, or that might come to your mind in the first go. But how can we solve it in some lower time complexity? Can you think of an algorithm that can solve this problem in, let's say, let's see your problem, what is the demand of your problem? So let's have a look. So problem says that expected time complexity is n log n. So can you solve it in lower time complexity than n square? So let's move to that approach, which is an important one. So let's understand this one once again. Okay. So the problem statement was 24135. Okay. 2, 4, 1, 3, and 5. This is your problem statement. So in this problem, count inversions. Now to optimize the approach, I will be making use of merge sort algorithm. Merge sort algo. How are we going to make use of it? Let's have a look. Okay. So if I apply merge sort algorithm, what does it do? It checks for mid element. Let's have a look. It checks for mid, right? Which is actually L plus H minus L divided by 2, right? Something like this. Okay. So if I were to check, and then it splits the array into two halves, right? And it keeps on doing so for until you get the array of unit length, right? And once you reach to the array of unit length, then you start merging the arrays, and those merged arrays will be in the sorted state. So once I start merging them, I get an array of length 2 that will be in sorted order. So that this will be returned to this particular array, right? Now this array in itself would be some sorted array. Similarly, this array, after when I'm backtracking it, it will be in some sorted state. Then call will be made to the function which split this array into two halves. Now these individual arrays are in sorted order. Then when they come back here, they also sort themselves, and finally I have made the original array, change it to the sorted state. That's how the merge sort algorithm works, right? Now how can we use this algorithm in this problem? Let's have a look. So the idea behind this problem is that I am actually counting the inversion during merge only. Just before we come on to the merge of this problem, just for an example, take two arrays. Let it be anything. Let it be two sorted arrays, two individual sorted arrays. Okay. Let it be 5. Let it be like this. Okay. Now just think of these two arrays and tell me one thing. Tell me one thing. If let's say I am sitting at this index and here I am sitting at this index. These are two individual sorted arrays. Okay. I will compare this value with this value. It says that this value ARR1 of I comes out to be greater than ARR2 of J. Do you see one thing here? If first element of this sorted array itself comes out to be the greater one than the first element of the other sorted array, then can I blindly say that the other remaining elements are also going to be greater than this value? Because the array is in sorted state. If first element, which is the smallest one, that element itself comes out to be the value which is greater than this element, then obviously other values are greater than this value only, so they are going to be greater than this, right? So making use of this information that both the arrays are in sorted state, right, I just make comparison during my iteration with current element, that is at I, and if I find it to be greater than the current element of another array, I can say that I can add my answer to count as what? Count will be equal to what was originally your answer plus how many such pairs or how many such inversions you will find. See, 2 turned out to be greater than 1. So 2 comma 1 would be one such array, one such pair which will be inversion pair. Another would be 4 comma 1. It will also be one such pair with this current element that I am evaluating for, which will count for inversion, right? So I will basically add whatever I will add 2, right? For this case it will be 2 because it is total length n. Let's say this was n2 minus your I, right? And that is the length that you are adding. So length is 2, 2 minus 0, right? So it will become n minus I. And then you increment the count of j. Let's check for, okay, let's check for the other element now. Again, now I'm comparing this. Now your I was here only. Okay. Now I compare this 3. Check this 3 with your 2. So what is it? 2 is less than 3. Nothing happens. It is fine. You increment count and come here. 4 is compared with 3. Is 4 greater than 3? Yes. And there are no more elements after 4. So my n minus I will be 1 only. So that 1 will be added. So I got 2 from 2, 1, 4, 1, 1 from here. And I think this is the end of iteration in this array. So I have got all my inversions. Now you will ask me, why am I checking for two separate sorted arrays and counting the inversions? Because the idea behind this is that I am going to find inversion pairs when I am during the merge sort, during merge of two sorted arrays. If you remember merge sort algorithm, see, for this problem it is a prerequisite that you are well versed with merge sort algorithm. So if you remember merge sort algorithm, as I also briefed above, that there is a step after dividing the arrays into two equal halves. When you combine it, when you merge it, you are basically merging two separate sorted arrays to form one another sorted array. So when I'm making these comparisons, what I'm doing is I have taken another bigger array which is equal to the size of this array plus size of this array, that is 5. So when I compare two, I'm doing two tasks during merge. You can say this is modified merge of array. This is like modified merging. So here, apart from merging, what happens in merging? From two sorted arrays, arrays, you make single bigger sorted array, right? That's how merge works, right? In this modified merge, one task is of merging, but other task that you are doing is counting inversions. So what you have done is you have broken down this problem into smaller problem by first dividing the bigger array into smaller halves, each bigger array into its two halves, and until we get the unit length of array, that is one element in your array. And then during merge when you are merging two sorted arrays, one element, if you are sorting with the other element, they are always in sorted state. So while you are merging them to make as one two in your sorted array, right, what you want to do, you just want to calculate the inversions also. And how can you calculate it? See, if left part is 1 and right part is 2, I can say that 1 is less than 2, so it does not form an inversion pair. So I need not to do anything, means I need not increase count of this inversion pair, and I can simply merge them and move ahead. Now let's say from one left array, you what you got was 1 comma 1 2, and another right array had, let's say, what can you have, let me make it, for example, this is 4 comma 7 and this is 3 comma 8. So you check 4 with 3, you check 4 with 3 while you want to merge them. Now you want to, let's say one left part is this and right part is this. Now you want to merge them in your merge sort thing, right? So here you will check, keep a check, your I is here, your J is here initially. You check, is your ARR of I greater than your ARR of J? If that is the case, then one thing, I'm just making a smart decision. Then if this smallest element of my sorted array is greater than the smallest element of the other sorted array, then all the elements that are after this element are obviously going to be the values that are greater than this value. So they are also going to be bigger than this element. So I can just write my answer, add to my answer that one pair this, other pair this, so I'm going to get a count of 2, right? So I have done this thing for all the remaining elements. Now I increment the count of J, right? And then I check again for 4 is less than 8, that is fine. I move to the next index, 7 is less than 8, that is fine, no need of checking. That's what I do, right? So that is the idea behind it. Now you will understand it better when we code it and maybe we do a dry run. So this is the entire intuition behind your problem. So I will tell you now, I will just dry run over this case 24135. This much theory was important for you to understand, otherwise, because this question requires you to have a good knowledge of merge sort, and then how we are using the concept of merge sort to solve this problem in a optimized way. Okay, now whatever I discussed, let's do one thing. Whatever I discussed, let me do a dry run over this test case. 2, 4, 1, 3, 5. Okay, let me just check if you guys have any doubt. Okay, so if first thing, what will happen is it will divide this array, right? So the divided array would look something like this: 2, 4, 1. Middle index would be this, so till mid it will go into left part, remaining part will go to right. For this, how will it divide? It will divide as 2, 4 and 1. For it will divide as 3 and 5. Then for this, it will further go and divide it into 2 and 4, and that is all. Now comes the merging part. When 2 and 4, when 2 4 are merged, so what will happen is during merge, we will also keep a count of, let's say, count is keeping the count of number of inversions required. So my I is at this position, my J is at this position. While merging, it will check if ARR of I is greater than ARR of J. No, that is not the case. Then I will do nothing, simply increment the count of, if it is less than, I will increment the count of I, it goes out of bounds. And also, let's say some temporary array I have made in which 2 and 4 will be added, right? So this 2 and 4 will now be compared with 1, right? And now 2 4, so this basically, this gave you 2 comma 4 and 1 gave you 1. Now 2 4 and 1 will be merged together. So when these will be merged, again same thing will happen. Same thing is what, that it will check for the comparison. It will, I is at this position, j is at this position. It checks if ARR of I is greater than ARR of j. Yes, it is. So in that case, my increment the count of 1, it will become 1 now. Right now it is 1. Now this was a smaller value, right? So wait, before I write it 1, what was my smart decision? If this element came out to be greater than this first element, or the element I'm comparing in the right array, I can say that all the remaining elements would form a inversion pair with that element. So how many elements are there after 2? So it's one more element. So that element plus all the elements that are after 2 will add to my count. So it will become 2, right? So, and finally, there will be a temp pair in which these will be merged using merge sort algorithm, and it will look something like this. Okay. So this 1 to 4, this array has now turned to this part of your problem. This recursive call in your merge sort has returned you array 1 to 4, and along with that it has returned you a count of 2 as well. Now let's check for these values. If 3 comma 5 were sorted, had to be sorted, then they will again check for same thing. 3 smaller than 5, nothing will add to count, they will simply get sorted, and sorted array would look something like this: 3 5 3 5. So this will return you 3 5, and this 3 5 will be compared with this array in its sorted order. So what sorted order was it? It was in this state, and this one would be in this state. Now the comparisons will be made between the elements, among the elements of left array and the right array. I hope you are understanding this. Okay, how will my comparisons look like? So it will be I is 1, j, I starting from 0, j is also starting from this right 0. So you can, ideally it would be at low, this value would be mid, this will be mid plus 1, and this will be high. So I will be pointing to your low, and j will be pointing to mid plus 1, ideally in terms of code. Okay, fine. So I compare this value with this value. This is smaller, 1 is smaller, so no worries, just move ahead. And also in your temp you are storing, that is your bigger array, that is the length of left array plus right array's length. Okay, and you are also filling up the elements in the sorted state. So one adds up, one comes in your temp array, the new array that you would want to return, right? Or see, actually for you, for explanatory purpose, in our problem statement or while we are coding, then also we will be taking a temp array, an extra array. But after running the entire function, finally I'll be storing all the elements from temp back to my ARR, the original array, because I split it, I combined it, and I finally want all the elements in the sorted state in my ARR only. I am modifying my original array only. That's what I'll be doing. Okay, for your understanding here, just understand that we are just taking temp. Okay, so one got stored here, and my what I need to do, one got stored here. Now I'm comparing this element with the next element, because see, 1 2 4, all of them are going to be greater than 3, and I have added the count of, sorry, 1 is less than 3, so I just come up to the next element of left and compare it with the right. So 2 is also less than 3, I simply add to temp and go to the next index in left. The thing is, the issue is when ARR 1 or left of I is greater than right of j. That is when I want to add to count, and then I will increment the count of j plus plus also, and k, and let's say this index is k, and k will be incremented every time we are filling it. Okay, now you are comparing 4 with 3. 4 is greater than 3. So first thing, fill up the smaller element. Which is a smaller element? The right indexed value, which is 3. And then you also Simultaneously, you count what is the count at this state. After 4, there are no more elements. So one such pair you have found. So count will your 1 will be added to whatever count it was earlier. Okay. And then what do? The smaller value was this. You now move your index to 5. Fine. Okay. Now what? Compare Comparing what? 1 with 5, smaller, 2 smaller, 4 smaller, nothing will happen. And also one important thing, this is for your explanation. When my j is at this position, at which position? I was already at the last of my left. Now in the next iteration, it will check while I is less than length of left, that is fact, and j is less than your right. So when I am at this index, I am doing what? I was comparing 4 with 5, right? I was comparing 4 with 5. 4 came out to be less than 5. So I will fill up the smaller element and increment the count of I. Now I is after left, means beyond the length of left. So I come out of this loop and I check if there are any remaining elements in the other array. I simply fill that up. So I hope this is clear to you all. Any doubts so far? Inversion after 2 4. Okay, let's understand. Inversion after 2 4. What happened is, see, let me 2 4 1 3 5. Let's take it for smaller element. Let's take our array as this. Let's assume that your array is 2 4 and 1, right? Let's say this is your array. These are two arrays. Okay, fine. Now what you are doing? You are running a while loop while I is less than, let's say its length is n, and j is less than m. Fine. So in this case, what are you checking? If ARR, let's say this is left, this is right. Okay. You are checking if left of I is less than right of j. That means you don't you will not find an inversion pair for that index I index value with jth index value in right. That means they are in the right order. If I want to, so see, my target is I want to see how this array will look like if all of them were in sorted state. So they would look something like this. And during this merge sort only, I want to calculate the count of inversion, right? So what I am doing is I am keeping this check. If left of y is less than right of j, then just simply in your new array, which is this array, temp of k will be filled with the smaller value because I want it in sorted order. So that will be filled with left of I, and simply increment the count of I plus plus and k plus plus, right? Otherwise, in else case is where you want to count the value. So count will be equal to what? Let's do this iteration. 2 is greater than 1, right? Now this is the else case part. Then what is happening is your count will be, this element will also form one inversion pair, and all the elements that are after 2 will also form the inversion pair because this array is sorted. So if first element, the smallest element of this array came out to be greater than this element, that means all the other elements of left are also going to be greater than this value. So they will also form inversion pair. So making use of this information, I am going to add 2 directly. And how I will calculate this 2? This 2 will be equal to the length. Let's say n is the length of left array. So n minus index I was at 0. N minus I will give me the answer for this step. So add n minus I, right, for your understanding. Okay, then what? Also in your temp array, you will fill up the smaller element. Temp of k will be filled with the smaller value which is present in right of j, and you will increment the count of j. Now when you increment the count of j, you will see that j has come out of bounds. So that means your current state of temp looks like this 1, right? And j has come out of bounds. So you will come out of this while loop and you will check whichever array is yet left to be processed, or in whichever array your index has not reached the length of that array, you will simply go and fill up that element, because that array already will have the elements in sorted order, right? So I hope this part is clear. Any doubts? Okay, so this is up till here. Now again, what we are doing, coming, if I tell you the pseudo code, if I talk about pseudo code, see, just an overview of pseudo code. You are merging, right? You are, how do you merge? You have an array, right? You have an array. Then in your merge, basically, you are doing the merge for two different paths. You calculate mid, right? Already, let's say mid is whatever mid is. Then you apply merge for first half, that is from low till mid, and then you apply merge for the other half, mid plus 1 till high. And I am saying, then you have already partitioned your array into halves, right? Into halves. In how many halves you could have until the length of your array is 1. So let's say we are calling this function recursively. When we want to merge it, that is when we want to do all of these things. So let's make another function of that with, let's say, count inversions or count merge, whatever function name you want to give. And in that I will be passing my arr, my low, that is for which elements I am trying to merge, my mid index and my high index. And in this function count merge, I will be doing all of these things. That is, while merging, I am keeping a check, which I just wrote here. This while loop will go in this merge function. Okay. And one more important thing. Now you will say, where is the count we are returning? So when we are writing this count merge function, we will take a variable, let's say int answer. Okay, and in answer, you will be storing these values, which will be stored by count plus 1 equal to, so answer plus equal to n minus I, however you will handle it. Now this answer will go to, let's say, this is giving you some answer, int result. So this answer will be returned to result. But do you see one thing? Each of these partitions were giving their own answers, and all of these answers need to be added up, right? So let's say I will store some int left answer in this part of your recursion, int right answer in this part of your recursion, and this result is getting its answer during the merging of the two sorted arrays, right? So inversions I'm going to get from here also. So all together, whatever the answers I have gotten from all the recursive calls and this merge call also, I am going to add it and return to my final answer. So my final answer would look like this. Fine. So let's move to the code and then you will be able to understand it better. Fine. This was about this problem altogether. Let's have a look at the code. Okay, if it's clear, great. If you still have any doubts, you can ask me. By the time I'm coding, I'll try to explain what are we doing here. Okay, so let's write a function. Just a second before you guys, let me check. In case you still have any doubts, you can ask me up. Okay, and you can have a look at what we did so far. I want you to just have a look at it, because code is also a little bit lengthy, so just you don't have to get confused while we are coding. Just once if you have understood the logic, then it's going to be very clear. See, I'll just keep it short. Okay, so basically we have an array, we apply merge sort algorithm, right? During merge there's just one catch. Simple. How do you do merge? You take a left part of your array, take a right part of your array, recursively call it, and then merge the sorted arrays together for each call that you have made. Just at the merge step, we are doing these calculations separately, these calculations which you see here. So these calculations will go into some other function which we have written as part of merge, And that is all that will be, that is the only modification and good amount of modification that we have done in your merge sort algorithm in order to calculate your count inversions. Fine. So let's go to the code and solve it. Okay, fine. So if I were to write a function, let's say long, and just be careful of what integer type data types they have used here, so we will use accordingly. Let's say merge sort or merge. Fine. Okay. Int arr, int low, int high, which will tell me the boundary of my array, the two halves, whatever it will be. So your merge, what is the base condition of your merge sort? That is when you reach only one length of your array, right? So either your low index, if low is greater than equal to high, either low is equal to high or low has reached greater than high. Understood? What you want to return, you return 0 in that case. And then you want to store answers for the left part of your answer, your right part of your answer, and the answer you are getting when you are merging the two sorted arrays. So left part would be calling the merge function. I am sorry, this will be long. Long will be merge. Here are low will be low and high will be mid. So what is mid? Mid is equals to low plus high, low divided by 2, right? Okay, long right is equal to merge, here are mid plus 1, right? Fine. And long other answer, let's say result, is one that you will get from the merging of two sorted arrays. So merging, let me write it as merge two arrays, merge two arrays. So you will be passing arr, your int low, your int mid, int high. Now I will be writing up this function. Fine. And finally, you will be returning your answer you got from here, answer you got from here, and answer you got from here. Sum of all the answer left. I'm sorry, left. Right. So if this is clear, let's move to the next function. That is, we want to write this function. That is the operations that we are performing while we are merging two sorted arrays. So I have already told you what we are doing. We are simply taking a new array, a bigger array that will be equal to the length of left and your plus the length of your right array, right? Because you want a bigger array now in which the elements will be in sorted order. But within that step, you are also calculating if you are finding some count inversion pair. And how you are calculating? You are calculating by comparing from an element from left with right, and using some information, you are just calculating your answer. Let's do that. And finally, I will be, after all the operations, I will be copying all the elements from that temp array back to my original array, because I want my original modification in my original array, right? That's how I'm passing, because I'm, see, in my merge, I'm passing ARR only, not some different temp arrays, right? So the modifications needs to be done in your original array finally. Okay, let's write it. Merge to ARR. Int low, int, sorry, it will be int of, I think array is also of long type, so you will write long arr, int low, int mid, int high. Okay, fine. So now what you are doing, you have your low, you have your mid, you have your high. Let's make a new array, as I told you, long arr, make it temp new long. What will be the length of this ARR? So you see that low and high are the extremes of the array that you are passing, and mid is the partition index of that array. So if I write it as high minus low, plus 1. That will be the length of my array. Let's assume this is 0. This is what? This is 4. In index, high will be 4, low will be 0. So 4 minus 0 plus 1 should be the length of your temp array. That is what we are doing. Okay. Then let's take an int I equal to 0. That will be iterating over the left part of your array. That is all array that is from low till midth index. Then int j, that will be iterating over the right part of your array. That is from mid plus 1 till high. So I will be equal to low, j will be equal to mid plus 1. Now do your operations. Your operations were while I is less than equal to mid and j is less than equal to I. Find what you are doing. If ARR of I, see here left and right part are coming out from your ARR itself. You are just handling it with your indices. So ARR, if ARR of starts from low, if ARR of I, it is less than ARR of j, that starts from mid, it will be mid plus 1. Okay, if that is the case, what you will do, first of all, store this value in temp of k. For that, let's take another variable int k equal to 0. So temp of k will be the smaller value, which will be ARR of I, and then increment the count of I and k. Otherwise, in else case is where you will be storing answer. So to store answer, let's take another variable which will be of type long, because finally you want to return long, right? So long answer equals to 0, right? So in else case, your answer will be equal to what? At whichever index you will be. Let's say your this case came only when ARR of I was greater than or equal to j, right? So what will be the answer in that case? That is what you need to understand. For example, if we are at 2, and let me write this thing, let me show you here. So let's say you were at 2, 4, 1, right? So 2 came out to be greater than 1, and this is low. Come on. This was low, this is mid, and this is high. Fine. You want to check how many elements can be the part of this count. So basically, left, whichever index you are in, left you will be at ith index. The end of left array would be mid index. So mid minus I plus 1 is the number of elements that will form an inversion pair with your element at j. So mid is 1, 1 minus 0 is 1 plus 1, 2. So that is how you are going to handle it, right? So answer plus equal to mid minus I plus 1, right? And then in temp, you store it, temp of k equals to the smaller value, which is ARR of j, increment the count of k and increment the count of j. And after you come out of this while loop, that is the case, either the length of left, either you have iterated the left part of your array completely, or you have iterated the right part of your array completely, or both of the parts are completely traversed. So if one of them is left untraversed, for that we are writing this case, which is while I is less than or equal to mid, simply temp of k should be stored with ARR of I, right? And k plus plus. Same thing for the other part. If let's say all the elements in your right part of your array were untraversed, so they will already be in sorted order. All I need to do is just store them in your temp array. Fine. Temp of k, ARR of j, k plus plus, j plus plus, right? Fine. Now once you're out of this while loop, and let's say if any of these while loops are hit, finally what you do is, let's say your I, finally the k value, k index comes at 0, and for I and t, let's say I is equals to 0, I is less than what? I is equals to low. and or you can write it as less than equal to I and I plus plus. Your ARR of I is equals to temp of A, right? And you can do it this way. So what are we doing here? We're basically storing all the elements from your temp back to your ARR, right? And finally, after this, you should return your ANS. This is quite a lengthy code. I'm expecting there might be some syntactical errors. Let's check. So here we are calling which function? We are calling your merge function. That's what we want to return. Return merge your ARR. Low will be 0 initially and high will be int of n minus 1, the last index of your array. Let's check. Merge 2. Same thing that I told you in the beginning of this code, that there will be lots of lossy conversions that we might find. What is this? Long left is equals to merge ARR low. I think this is fine. We took it int only everywhere. Is it needed to be converted to low mid? Let me check it. This is fine. This is fine. Okay, it can be int only. Fine. Let's check. What is this? 72. Low is int, high is int. Unreachable statement. 78. Let me check this. Oh, let's check it now. This was the base condition, right? So I've written it separately, and this all comes out of your base case condition. Let's check. So there is some mistake again. What is that mistake? Let me check. High minus low plus 1. Let me know if you guys can figure out this mistake. Let's check it by that time. Long temp, I minus low plus 1. I low int j k answer. K I have put to 0 again. K plus plus I is less than or equal to high. Okay. Return ANS. I think this should work, but let me check it if I have made some error. Let me just make a dry run long temp. Is less than or equal to high. I think this also makes sense if ARR of I is less than ARR of J. We are doing this, or let me check if, let's check, that was the issue. So I hope you have understood this problem. I wouldn't say it's an easy one, or even I wouldn't say it's a medium problem also. But if you have understood merge sort algorithm properly, then logically it's easy, or you can say easy to medium. But just you have to take care of how you are handling the recursive calls. And here they have just used the data type long, so that sometimes causes issue, means in passing it in one go only. That's the issue with this problem. But if you have understood the explanation, there is nothing much, right? So that's all about this problem. If you have any doubt, you can ask me. Fine, everyone, then that was all about this problem. I'll just come back to this, and I would like to come back to what we discussed. It was, we have an array, we divide into two equal halves like we do in the merge sort, right? And what happens after that? While we are merging in the merge sort, if you remember, we merge them on the basis of the comparisons. Here also we are doing the same thing, but with an additional check, that if you get an element which is greater than the element you are checking in your right part of your array, you just make use of the information that left array is also sorted, right array is also sorted. So all the elements after this element will also be greater than that element. So you will manipulate your answer accordingly and add it to your to the final answer that you want to return. So that is about this problem. See you all on Monday. We'll be discussing the next problem. Okay, thank you everyone. Bye bye.